What's going on, everybody? So last time we talked about quartiles. This time we're going to implement the quartile concept into calculating and determining the interquartile range, which is another measure of spread. Previously we've talked about the standard deviation, but this one's kind of a little different one, and we'll see when to use which one and what exactly the interquartile range can provide us in terms of information about a data set. So let's go ahead and get started. And here we are. So let's talk about the interquartile range conceptually. A higher interquartile range, which I'm going to go ahead and abbreviate by IQR, and this is a typical abbreviation throughout several books and multiple professors use this, tells you that the observations are further away from their corresponding median. So very similar to the standard deviation that corresponded to the mean, right? So we had the further away from the mean it was, the higher the standard deviation was. Here we're talking about for the median. So we're using the median as a measure of center, and the measure of spread is the interquartile range. It's basically how far is the data from that given median. And so it follows that an interquartile range of 0, kind of like standard deviation being 0, means that all observations are equal. Equal to what? In this case in particular, they're equal to the mean, right? So if the median is being used as a measure of center of a distribution, the corresponding measure of spread is the interquartile range. Kind of, again, this is just very parallel to what we were talking about with the mean and standard deviation. If you pick the mean as your center of the distribution, then you should pick the standard deviation as a measure of spread. Median, you go to the interquartile range. Now the best situation to use the interquartile range is when the distribution is, so remember before the standard deviation was used when the distribution was what? Symmetric or skewed? It was used for when the distribution was symmetric. So the interquartile range is used when it's skewed or has extreme outliers, right? So any of those two situations kind of mess things up a little bit when we're talking about the mean and standard deviation. But with the median and interquartile range, those are a little more robust measures and are able to tell us a better measure of center and spread, even if there are outliers or if the data is skewed. And so the interquartile range is determined by the following. So it looks pretty simple, right? It actually is way simpler than the standard deviation, so it's not as much of a headache, but you have to do a couple steps, a lot more steps actually, prior to being able to find this interquartile range. But essentially it's Q3 minus Q1. And that's about it. So it's the third quartile, or Q3, which kind of separates our third quartile, and Q1, which is the number that separates our first quartile. Once you figure those two out, you just subtract them and you find the interquartile range. Simple as that. So now let's move on to the 5-number summary. So now that we have kind of all this information, we can compile it and get a numerical, a numerical depiction of this distribution. And so the 5 numbers that we're going to be needing is the minimum, which is the first one. We have Q1 is the second one. The median, which is the third one. Fourth is Q3, and fifth is the maximum number. So let's go ahead and try practicing determining the 5-number summary for the following data set. So what should we do from the get-go? We've already seen this multiple times. The first step when we get a data set and we're trying to find medians and things like that is to put it in order, right? So 15, 24, 34, 56, 67, and 80, right? So now we can start off with the minimum. What's our minimum number? What's our minimum value in this data set? It's literally just the first number, right? So it's 15. What's the maximum going to be? The maximum is going to be 80. Next, Q1. Q1 we can't really get without the median, right? So we have to get the median first. So how do we get the median? Remember the median, all you need is n plus 1 over 2. So what's our sample size? Our sample size in this case, we have 1, 2, 3, 4, 5, 6. So 6 plus 1 in parentheses, right, to tell your calculator to add that first and then divide by 2, equals 7 over 2, aka 3.5. So the 3.5th, for lack of a better word, observation is 15, 80, 24, so it's somewhere between 24 and 56. I'm sorry, 34 and 56. So how do we get the median then? Just like we did before, the median, if it's in between two numbers, all we have to do is find the average of those two numbers, right? So 34 plus 56 over 2. So what do we end up getting? It's 90 on the top. Divide that by 2, we get 45. Alright, another number down. So we got 3 out of 5. So how do we get Q1 and Q3? Q1 and Q3 are essentially just the midpoints of what the median already split up. So the median kind of split up 24 and 56. So now 24 to the left and 56 to the right are two different halves of the distribution. Now we split those halves in half again. So good thing is that there's only 3. So since there's 3, there's 3, there's 3. You take out the left and the right one, and you're left with the midpoint, which is going to be the middle finger. That's inappropriate, but moral of the story, that's what we're going to need. So Q1 is 24, and Q3 is going to be 67. So 24, 67. And the last one, even though it's not part of the 5-number summary, we can find an interquartile range if we have to. So let's just practice doing that. So the interquartile range is equal to, like we just said a second ago, Q3 minus Q1, right? Q3 is what number? 67, right? We already found that. And Q1 was 24. So our interquartile range ends up being 43. And again, these are the 5-number summary. And then the last one, interquartile range, we'll kind of see why it's important in a second. So what does the interquartile range do? Not only does it measure spread, but it also allows us as statisticians to determine if there are any outliers within our data set. Now what's good about that is that most of the times before, when we were talking about outliers, it kind of was like a super extreme value and we could totally tell it was an outlier. But what if it's the case where you're not really sure if it's definitely an outlier or if it's just a really extreme value, right, within kind of given interval? The interquartile range allows us to come up with literally an interval for which inside of it, the data within that interval is not an outlier. Outside of it are super extreme values, and we consider those outliers. So let's go ahead and find out how we can come up with this interval. So the most commonly used rule to detect outliers is to use the 1.5 times interquartile range. So now what does that really mean? So lower outliers, so the ones that are super extreme to the left, are any numbers lower than 1.5 IQRs below Q1. So let's draw a little distribution here. Let's say here we have Q1, right? And here we have Q3. Now Q1 and Q3, the distance between those two is the interquartile range, right? Now 1.5 interquartile ranges below Q1. This is kind of sort of not drawn to scale, but it's okay. So the 1.5 interquartile range below Q1 gives us kind of this fence here. Or not a fence, I would like to say an interval. Right, so it gives us the lower end of the interval. And so basically anything below 1.5 interquartile ranges of Q1 is going to be seen as an outlier. Now, let's go ahead and move on to the other side, right? Because we have a lower extremes and we also have higher extremes. So upper outliers are those higher than 1.5 interquartile ranges, above Q3. So we do the same thing on the other end. Here's 1.5 interquartile ranges, and here's going to be basically our fence to determine, make this a little longer, our fence to determine whether something is extreme or not. So now, basically any data out here on these edges are so far off from the median or our center of our measure of center, right? Because our median is going to be somewhere over here. Not maybe in the middle. It might be a little closer to Q1. It might be a little closer to Q3. But somewhere in between those two, right? So these numbers are so far off to the left and right that they're considered outliers. Anything out here, we're going to consider them being outliers. Cool? So super huge drawing just to give you a picture of what this kind of does. But we don't actually have to do that. We can come up with upper and lower limits just by using Q1 minus 1.5 IQRs and Q3 plus 1.5 IQRs. So let's go ahead and apply that and see kind of how that works with example 2. So example 2, we're basically just looking at the same data set from example 1, and determining if there are any outliers in this sample, right? So what do we need? First off, we need the interquartile range. Let me just go ahead and rewrite these down here so we don't get lost. So Q1 is 24, Q3 is 67, and the interquartile range we found was 43. So let's go ahead and find 1.5 IQRs. So 1.5 IQR is literally 1.5 times the interquartile range. And so once we multiply that out, that gives us 64.5. So what do we do with that information? So once we have the interquartile, or 1.5 times the interquartile range, all we really have to do is get Q1, subtract 1.5 interquartile ranges, get Q3, and add that. Does that make sense? And then we come up with this grand interval for which inside of here there's no outliers, and again, outside there are the outliers. So let's say upper limit. The upper limit is Q1 minus 1.5 IQR. So let's go ahead and start plugging in numbers. So Q1 is 24 minus 1.5 IQRs was 64.5. So we end up getting negative 40.5, and that's fine that it's negative. It's just somewhere really low, right? So it's just a really extreme value. Sometimes it may be negative, sometimes it's positive. It really just depends on the data. And then the lower limit, I'm sorry, that was the lower limit. Duh. So it's Q1, sorry, just making sure you guys are paying attention, right? So Q1 minus 1.5 IQRs gives me the lower one. Now let's go ahead and do the upper one. So the upper is going to be Q3 plus the interquartile range. So Q3 was what? Q3 we got was 67 plus 64.5. So that ends up giving us 131.5. So, do we have any outliers in our data set? Yes or no? We actually don't, because all of our data actually falls between the interval of, so let's go ahead and just draw this little thing here. So here's kind of some cutoff, and here's negative 40.5, and here's the other cutoff, 131.5. All of our data actually lies somewhere in between all of this. So we're actually good, because that means that there are no outliers, right? Because our data is in this little interval where we said this is kind of normal, it's not too extreme, not too crazy. But if there was, for example, an observation that was 140, 140 is to the right of 131.5, that would have been an outlier. So here we get to see how to calculate an interquartile range, and actually not only is it used as a measure of spread, but it's also used to determine whether there's outliers within your data sets. So we're going to go ahead and move on to now bringing it all together and how to construct a box plot. So until next time, take care, guys.